Hello and welcome back to Try Again Dev. Here at Try Again Dev, we know that we don't start off perfect. We try and try and try and try and try again until our code compiles, until we solve whatever we're trying to get to. Practice doesn't make perfect. Perfect practice makes perfect. Practice makes progress. So today, let's see what we can get into. Okay, so today our mic is set up. Let's find ourselves a Leetcode problem to work on. So far I've gotten up to about 10 problems solved, which is pretty cool, pretty great. Or 9, okay. So I think let's look for number 10 today. Okay, so earlier I started looking at like easy problems and saying like, let's try to get through the easy problem set first, and then we could go spelunk a bit deeper with some of the medium problems and some of the concepts that we might feel more comfortable with. Oh wow, okay, yeah, we've gotten through a good number of the easy problems here, but as we know, like practice makes progress. I might not solve the problem, but getting the exposure, doing the research, putting in the work and the time and the effort is what gets us to the next step. Okay, so today it looks like our problem is best time to buy and sell stock. And let me just make sure that everything is good with our stream here. Okay, great. Looks like we're streaming today. Okay. Alrighty, so best time to buy and sell stock. Sorry, I'm just gonna check the volume because I did do one where it was not recording. Anyway, alright, so best time to buy and sell stock. You're given an array prices, where price is I, okay, but it's an array, not like one of the last ones where we had a class and such. Price is I is the price of neat coin on the ith day. Okay, great. You may choose a single day to buy one neat coin. Oh, I get it. Okay. And choose a different day in the future to sell it. Choose return the maximum profit you can achieve. So as they have here, our profit is a number or integer. You may choose to not make any transactions, in which case the max profit would be 0. Okay. So I believe they had a sliding window as the like what we're gonna do here. And we see the prices as less than I, prices I, the number of items in it is gonna be 0 or more, 100 or less. And they would like us to solve this in O of n or linear time, aka like one for loop, and O of 1 space or in place. One of the things I learned from AlgoJS, which shout out to them, is that if you do stuff in place of the array that you're going to return, that actually like doesn't count towards your space complexity. But like if you were storing stuff in another array in the middle of the problem without returning that array, that would count towards your space complexity. Hope that made sense. If not, drop me a chat, write me a comment, let me know, and I will address it in another video. Okay, though, for today, what are we looking at? So we get our array prices. It gives us essentially the price of stuff. And we need to find like essentially the max difference from one point to a point in the future. So like, let's just say we were trying to draw out this array that we got here. 1, 5, 6, 7, 1. Okay, so like this is your overall like price situation. And then like this is your early minimum here. And this is the maximum that's like after that first minimum. And then what we'll also be looking for is this difference, like the difference between the maximum and the minimum, as like what we'd be wanting to return. So it sounds like we should be able to like loop through the array, loop through array, and then store to store a maximum, but like the maximum after the local minimum. Right? And then we can store the minimum, and we can store like the maximum difference. Okay. Okay, so now that's kind of the overview we'd be looking at here. But then like part two of this is like, what do we want to do to compare like the value to the value before it, the local max, the local min, all that good stuff. So let's go back through the array here that we've created or been given and see how we would interact with the different points here. So at the first point, this becomes our max, our min, our first love, everything we could have ever dreamed of, until we get, oh, and the max difference would be 0, because that's the only thing we have here. So like also if we were to get an empty array, we would be returning the max difference at 0. If the price only went up and we never got something lower, we'd be returning a max difference of 0. So actually before we get into the rest of the code, let's set this up to get us started here. So the return let max so far equal 0. For I plus plus. Okay, and the reason we go less than prices.length is because we start at 0, and as we know, computers count from like if we were having this array with the numbers 1, 2, 3, 4, 5, we'd have this other array with the positions, and that starts at 0. So 0, 1, 2, 3, 4. So like when we count the positions, which in a for loop we're defining things based on the positions, we have to start at 0, and so it has to be less than the length of this array, which if you do a length operation, you get 5 because there are 5 items in the array. But since array counts start at 0, 5 items means we count from 0 to 4 or less than the length, prices.length. Okay, so we said we would define these items. We have now defined these items. Now, how do we want these items to interact with each other? So definitely if prices.length is and we just return answer. say let here, or else our code won't. If, right, because we said we do some if blocks. So if P of I, or prices of I at position I is bigger than min so far, which it will be. Oh wait, the first one's gonna be 0 though. Well, let's try the code out and see what happens, because I think since we're doing a subtraction operation, the diff is gonna equal itself out to be 0, because max is gonna be 10, min is gonna be 10, the difference of that is 0. So let's just write the code. So yeah, if prices at I is bigger than the min so far, then max after min is going to equal math.max of max after min. Why are you saying, oh, you are saying you've been touched. Okay, great. Current value. Let our answer difference is going to equal, and then we said this is also a math.max of current diff answer difference is if prices, position I, is less than previous, then we would want to set our min to the present value. And like before we're done with the loop, we're going to set previous equals current value before we loop and lose all that information. Okay. Just wanted to write that down so I don't forget it. All right, so then here we have min so far. Yeah, if prices I is less than the previous value, because this is less than the previous value. Okay, me to me. If prices I is less than the previous value, we are updating the window to move from here to here. If the current value is bigger than the max so far, max after, yeah, which in this case it is. How do we keep our window? Oh, you know what? If the current value is equal to the max so far, or more than the previous max was, then this is gonna have to be like a window from this value to this value. Okay, so we can write that as a next step. Awesome. Or somewhere around here. I'm gonna write that as a comment for now. If x difference, do difference? Think about that in a second. So if the current thing is less than the previous value, then we want to look at, I think I was saying min so far, let that equal the current value. What is this? Oh, okay, let it equal the current value. Yeah, I guess current values less than the previous value, then min so far, set that equal to the current value. I guess. I'm just thinking now about like, even though this is a sliding window problem, which means we'd be keeping track of two things, I think of keeping track of two things in the way of like two pointers, because I'm like, why not just start at the end of the array? Like, what are we looking for? We're looking for the biggest thing, the latest in the array. Technically the biggest difference between stuff, because if we look for the top thing, then it might not have as big a difference. It might be like way high at the top and then like falling or something weird like that. I'm just gonna run this and see if it even compiles. Okay, I wonder what's going on here. So 7, 1, 5. Okay, if I were a human doing this, how would I approach this problem? If a number is bigger than the next number, we kind of throw it in the garbage right away. If we have a baby number, then we have a bigger number, we store the little number, the big number, and the difference. Now this is smaller than this number. It's not smaller than this number. So we can ignore it. Yes. Yeah, if this number is between these two, we continue. Okay, so let me write this in words of like what I'm thinking through here as like a human if I were to solve this problem. store value. If store difference. If number in range, continue. Biggest, min, and max, continue. Okay. And then this one is out of range between min and max. So store difference, oops, not what I intended to do there. Store wait, what? Sorry, I just got and current is math.max of a number. Yeah, that's what we have to do is smaller current min. We'd have to store and set current max if not prev, and set that here. Honestly, we don't even have to do that. We could do that here. That prev equal prices 0. Like, no need to do one-off things in our form. Okay, so we've stored our first value. Current is prices. If next number in range between min and max, continue. All right, so and because we're pretty much saying like if it's in the range of the maximum situation, we're not going to do anything about it. So just going to put that text block there. Now, if the next number or the current value, then the current max value is bigger than Is that what I call it? No. We're going to call this difference. Okay. Difference equals difference between math.max. Okay, of the previous difference and the current max minus the current min. You can do that. Doing the previous difference, the current max minus the current min. Okay. If the next number or the current number is smaller than current min, so if current, or no, min so far, if current value is smaller than min so far, we could take this one and flip the sign. So it's 0, and we'll take that for a ride. I don't think I'm using the previous thing anymore. Yeah, that's funny. Okay, well, why did I say I was storing the first value? Should we store it as something? Yeah, I think the current value should be stored as, should it be the current max or the current min? The min so far. Min so far. Yeah, because if the next number is bigger, we can replace it. Yeah, and then we return the difference. Okay, let's see how that goes. There's a problem. Let's see what the problem is. Let min so far is price is 0. Okay. So is it because it's a different? Oh, okay. Because I don't need to have let again. Great. All right. Diff is not defined. Diff should be difference. What line is that? Here. Okay. Hey, at least we got one thing right. Is that an empty case? Oh, wow, it's not even. Huh. How is this 0? Really? Oh, okay, it decreases. Awesome. All right, so I guess in that direction it works out. All right, let's do this again with console logs everywhere and see where our logic has not yet come up. Min so far, current value. So what would I want to do here for console logs? Okay, I want a console.log where we are, which I'm gonna write a number. Difference. which is current value. And the max so far, yeah. Which max? Okay, similar here. I'd want that we're in 3, current, max, previous. So far. It's a current max. Current max. Okay, let's try that. Great, okay. All right. So, ooh, max is 0 all the time. Okay, so I have to set the max somewhere. Current value is bigger than current max.